Hello everyone, welcome back to my channel Gems of Knowledge. So here I am with another interesting video on extraction of metals from their ores. In the previous class we have studied about the step 1, that is enrichment of ores, and if you are not aware of it, the link will be provided in the description box. Go and watch it. And in this today's video we are going to study of step 2 and step 3, that is extraction of metal, the 3 steps, how it is different for low reactive metal, moderate reactive metal and for high reactive metal, and the step 3, that is refining of metal along with the electrolytic refining experiment. Okay, so before starting my video, make sure to subscribe to my channel and also click on the bell button to get the notification as soon as I post my new videos. Okay, so now let's start with the video. I hope you people remember what is enrichment of ores. So now the step 2 we are going to learn, that is extraction of metals. Okay, so to learn this extraction of metals we need to study few steps here which are shown here. The steps which are involved in the extraction of metals from their ores. So I hope you people remembered I asked you in the previous video what is metallurgy. So here is the answer for it. The extraction of metals from their ores and then refining them for use is known as metallurgy. So this is nothing but a basic definition for metallurgy. The extraction of metals. So already the metals will be present in their ores in the earth's crust. So extracting that metals and then again refining them to use it, so that process is nothing but known as metallurgy. So you are going to study what is extraction of metals and even refining in the same video itself. Okay, so there are few steps which are showing us how the extraction of ores metals have been done from their ores. Okay, so here you can see one ore has been given, and from that concentration of ore we are taking, and in that concentration of ores, so we get different types of metals according to their reactivity. So first we will take the metals with high reactivity, then secondly we are going to consider the metals with medium reactivity, and at last we are going to consider the metals of low reactivity. Okay, so first we'll see metals with high reactivity. Okay, so the metals with high reactivity, so how the pure metal can be obtained. So there is a process, that is electrolysis. Okay, so we are going to study this in the further video. Okay, so the electrolysis of molten ores. So whatever the molten ores will be present, that is done with an electrolysis. Okay, so you can see here in the previous video we have studied that the very reactive metals, how they will be extracted by the metal earth crust, extracted by the earth's crust. Okay, so it is not found in the free state and we have to extract it by the process of electrolysis. So we'll be studying this electrolysis process in this video itself in the step 3, that is refining of metal. There we are going to study it. So that process is used here before extracting that metal. Okay, then after the electrolysis what we are getting here is nothing but the pure metal. So this is in the case of metals with high reactivity. Now we are going to know the metals of medium reactivity. When the metals with medium reactivity are found in the nature, they are nothing but in 2 types of ores, either carbonate ore or either sulfide ores. Okay, so these 2 types of ores, when they are in carbonate ore, there is one more process called as calcination, and when they are in sulfide ore, one more process that is known as roasting. So these are the 2 processes by which we can get the oxide of that metal. By which we can get the oxide of that metal. Then after we are getting the oxide of that metal, the metal oxide will be reduced. So we have to do the reduction process here, and after that we have to do the purification of that metal. After the metal is been reduced, the metal will be purified and we are going to get the pure metal. Okay, so in the case of metals with low reactivity, here it is almost found in the sulfide ores. Then here the same process, the sulfide ores means the same process here, the roasting will be done. Then we are going to get the metal, and after that we are going to refine that metal. Okay, so all these processes we are going to study now. So the first thing what we have to know here is we are going to study the extraction of metals. Okay, so as you can see here, first extraction of low reactive metal. So we have started from here, the metals of low reactivity. Okay, so extraction of low reactive metal. Hence, oxides of metals can be reduced only by the process of heating. So here we can reduce this metal oxide only by the process of heating. For example, reduction of cinnabar. Cinnabar is nothing but this compound, that is Hg and S. This is nothing but mercury when mixed with sulfide ore. Mercury when it is mixed with sulfide, it is called as cinnabar. Okay, to mercury. So what we have to do? We have to reduce this cinnabar to mercury. It means we have to remove the element sulfur from here. Okay, so you can see what is the process here. When 2 times 2HgS plus 3O2 is heated in presence of, when this cinnabar is heated in presence of oxygen, we are going to get the metal oxide. We are going to get mercury oxide plus 2SO2 sulfide ore we are going to get here. Then again this mercury oxide when it is heated with mercuric oxide. So again this mercuric oxide when it is heated, we are going to get the pure metal and oxygen gas will be liberated out. Okay, this is in the case of cinnabar, that is when the mercury is mixed with sulfur. Similar here you can see reduction of Cu2S, that is copper sulfide. Okay, how we can remove the sulfide of copper to copper? So again we have to heat this sulfide, copper sulfide with oxygen in presence of heat. So we are going to get copper oxide and SO2. Then again when this copper oxide is again heated with this ore, again we are going to get this copper we are going to get, and this S and O2 will be released out. Okay, sulfur dioxide. Okay, this is in the case of low reactive metal extraction. This is how the extraction of low reactive metals can be done. That will be the process will be slightly changes in cases of all the different types of metals. As you can see here, we are going to get the oxide ores. Similarly, we are getting oxide ore, but here when we heat this oxide directly, we are going to get the mercury. But in the case here, again we have to heat it with the copper sulfide itself to get the pure copper, and the remaining sulfur dioxide will be released out. Okay, so this is in the case of low reactive metal. Again we have to study about the moderately reactive metal, that is medium reactive metal, usually formed as carbonate or sulfide ore. So you can see here we have studied that it is usually formed in the carbonate ore or sulfide ore. Similarly, it has been mentioned here that it is formed in the carbonate or sulfide ore itself. Okay, so here the process next. When it is formed in the carbonate ore, which process we are using? That is nothing but calcination process we are using. So here you can see calcination process. The carbonate ores are changed into oxides by heating strongly in the limited air. So whatever the carbonate ores were present, they are changed into oxide. They can be changed into oxide by heating it by heating strongly in the limited air. So in the limited quantity of air it has been heated, and then the carbonate ores which are present, it will change into oxides. This process is called as calcination. So you can see the example here. When the zinc carbonates are formed, we have to heat it in limited quantity of air, and we are getting the zinc oxide, and CO2 carbon dioxide will be released out. Okay, so similarly you can see roasting. Roasting is the process to convert the sulfide ores. Okay, so you can see sulfide ores are converted to oxides by heating strongly in the excess of air. So this process is called as roasting. Okay, so here we are using only limited air to remove the carbonate ores, okay, and to change into oxide. But in case of sulfide ore, when it is sulfide ore, we need excess of air to convert it into oxides. Okay, so here you can see when it is sulfide ore, ZnS, zinc sulfide. So we have to use this much of oxygen, excess of oxygen, and when it is heated, okay, then we are going to get zinc oxide, we are going to get here, and the remaining SO2 will be converted, sulfur dioxide will be released out. Okay, then after these two processes, you can see we are going to get the oxide of metal. Do you know this? The space smells like a combination of hot metal, fuel and barbecued meat. Yes, you heard me right. Space, it smells like a combination of hot metal. When we combine hot metal, fuel and barbecued meat, so the space smells exactly like it. Then for this oxide of metal, we have to make a reduction process. So what is reduction process? You can see here, metal oxides are reduced to corresponding metals by using reducing agent like carbon. So they are using carbon as a reducing agent, and they are from the metal oxide they can get the metals. So you can see the example which is given here. ZNO, zinc oxide, when it is mixed with a carbon, what we are going to get is zinc metal we are going to get, and carbon monoxide, that is CO, will be released out. Okay, so you can see what is thermite process here, the process in which molten metal oxide. So here what they are using, molten metal oxides has been used, and it is treated with aluminium powder. So when this molten metal oxide is treated with aluminium powder, that process is nothing but called as thermite process. Okay, it is highly reactive. This process is highly reactive. It is exothermic. A large number of heat will be produced by this process, and this molten metal obtained is used for welding railway tracks. Yes, can you imagine this metal, when the molten metal oxide is mixed with the aluminium powder, it is used for welding those railway tracks or cracked machine parts, the big machines which can be used in the industries and all. When it is cracked, this process, by the use of thermite process, the cracked machine parts are repaired. Okay, so just an example they have given you here, that is 2Al, that is nothing but aluminium powder. So when we are using aluminium in the molten metal, that is Fe2O3, it is nothing but called as hematite. When they are using this aluminium powder in this hematite, we are going to get 2Fe, iron plus aluminium oxide, Al2O3, and a huge amount of heat will be produced. As this is a highly reactive reaction and exothermic, a huge number of heat will be produced out. Okay, do you know this? Iron is most widely used metal, but it is never used in its pure state. So do you know why? If you know the reason behind this, go to the comment section and write your answer. So if you are not aware of the answer, wait for my next videos. So I'll be providing the answer to this question in my next videos. Okay? Till then, get subscribed to my channel and also press on the bell button to get the notification. So if you are not getting the notification, you are definitely going to miss the answer for this question. Okay, you can see the third process here, that is the third step in the extraction of metals, that is extraction for high reactive metals. Okay, so here the metals cannot be reduced by reducing agent. So in the previously middle reactive metals, we have seen the metals can be reduced by the reducing agents. So here that process is not possible. Here the extraction takes place by the electrolytic refining methods only. So here the refining of metals can be here the extraction of metals can be taking place with the help of only one process, that is electrolytic refining metal. Okay, so here for the example, what we have to remember here is extraction of Na from NaCl. Okay, and here you have to remember Na will be deposited at the cathode and Cl will be liberated at the anode. So the process, the experiment we'll see after this, after the third step, that is nothing but the refining of metals. So what is this refining of metals? So here we are studying electrolytic refining. So what is this refining? Okay, the process of purifying the impure metal to pure metal by different processes. this type of method is this type of process is nothing but called as the refining of metal. So it means we are going to purify the impure metal into the pure metal here. Okay, so let's quickly have a glance on the electrolytic refining experiment here, where the copper sulfide has been used. Okay, so in case of copper sulfide, we are going to see the electrolytic refining process. So let's quickly have a glance on that experiment. Okay, so let's start with our experiment. So here you can see the experimental setup of electrolytic refining of copper. Okay, so here you can see one cathode is present, one anode is present, and this is a tank which is shown here, and inside the tank there is a solution of acidified copper sulfate. Okay, so this is nothing but the electrolyte which is used here. So you need to remember one more thing here, that is the anode is completely made of impure metal and the cathode is completely made of the pure metal. The metal used here is nothing but the copper. Okay, its solution, what happens here is the impure metal which is present at the anode, it will dissolve into this copper sulfate solution. Okay, so as soon as it dissolves into this copper sulfate solution, what happens? The same amount of pure metal from the electrolyte is deposited at the cathode. So whatever the pure metal will be there in the electrolyte, that is deposited to the cathode. Okay, the insoluble impurities which are present inside this solution, this electrolyte, it will settled in the right side. Here you can see below the anode, and that is nothing but called as anode mud. Okay, so here you can see E present here, it shows some direction, that is nothing but the flow of electric current. That E shows nothing but the flow of direction of the electric current. Okay, so I hope this experiment of electrolytic refining of copper is clear to you. If you are having any doubts regarding this, you can comment me down below. I'll surely help you out on this matter. Okay. So far in the previous videos, we have studied about the extraction of metals and its refining. So we need to study few questions related to this, which is on page number 53 of your NCERT class 10 textbook. So we have to go through those questions and try to solve it. So let's see what is the first question here. Define the following terms. So few terms have been given here and we have to define this following terms. So first one is minerals, second one is ore, and the third one is gauge. So you have already studied this three into my video. So let us repeat it. So the solution here is, if you forget the solution, you can check it. Already I have been taught you this in my videos. So you can press the pause button and copy down if you need it. Okay. So let's move on to the second question. Name the two metals which are found in nature in the free state. We have to name two metals which are found in the nature in a free state. So the solution here is gold. Gold can be written as AU as well as silver, AG. These are the two metals which are found in the free state in our nature. Okay. So the last question of this page number 53, that is, what chemical process is used for obtaining a metal from its oxide? So which is the chemical process for obtaining the metal from its oxide? We have to name that chemical process. So the answer here is nothing but reduction. By the process of reduction, we can obtain metals from its oxides. Okay. So that's all for today. If you like my video, do hit the like button and also hit the subscribe button if you are new to my channel. And if you are having any doubts regarding this, please comment me down below. I'll be back soon with another topic, so stay tuned and stay connected. Thank you.